Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of the compound interest topic, where we're actually finally going to start to go through compound interest questions. There is a bonus video on what is the difference between simple and compound interest if you would like to check that one out as well. I will link it here and also down below. So let's jump right into it. This is the formula for compound interest. I've obviously written it in my own way. If you prefer to use different letters or write it in a different way, that's absolutely fine. It doesn't matter as long as you can remember it and put the right numbers in the right places. It doesn't matter what letters we use. This is just what I went with. I've written the initial amount. We then times it by 1 plus the interest rate over 100. So basically what this means here is just like the decimal version of the percentage, right? Because you know how percentages, when we use a calculator, we actually have to put them into a decimal format. So you don't necessarily have to use this fraction as long as you're happy with literally converting any percentage into a decimal. Just do 1 plus that percentage, okay, as a decimal. Then this bit here, just the bit here with the 1 plus the percentage, is to the power of the amount of time. Most of the time, this is in terms of years. So as you can see, I will have the formula on each question. Okay, so don't worry about that, but do make a note of it however you would like to, because it would be helpful to memorize it. Now, saying that this is the compound interest formula, I just want to make it clear, this is the formula that will give you what we call the value of the account at the end of, whatever the amount of years it is. It won't tell you what interest has been added on its own. It will give you the value of the account. So that means whatever they've first invested plus all the interest added. So let's go through a question or two and then you'll see what I mean by that. So, in this context, Jane invests £3,000 into an account paying compound interest at a rate of 2% per annum. If you haven't seen the simple interest video, per annum just means per year. It's just a fancy way of saying that, basically. So 2% per year. And they also have to specify what type of interest it is, because we do have technically simple interest and compound interest, and they work differently. So if it's more than 1 year long, they will have to specify what type of interest, just so that you know. Okay, what is the value of her account after 4 years? So what we're looking for, if you look at this formula, there's 3 bits that are missing, aren't there? The initial amount, the percentage interest rate, and the time. So all you really need to do in terms of this question and the way that it's worded is pick out those 3 things, okay? And just put it into the formula, put the formula in your calculator, because this will be a calculator question, and then write down the answer. So if we were to match it up, for example, we've got the initial amount, which in this case is the amount they're going to invest. So we're starting with £3,000. We're going to have the rate or percentage interest, whatever you want to call it, which is here. And then we're going to have the time, which is this one, 4 years. So all I need to do in this case is write down, obviously I know you're going to put it in your calculator, but also write it down so you get the marks for the working. 3,000 times by, now if I'm to copy this exact formula, it'd be 1 plus 2 over 100, because that converts it to a decimal, and then to the power of 4. Now you can see again, the power of 4 is only for this bit here, it's not the whole thing to the power of 4. What I'm more likely to do, because I'm quite happy with what we call multipliers. Multipliers is basically like decimals or percentages when we put them into decimals, and obviously we're multiplying by them. I would do it like this, 3,000 times 1.02 to the power of 4. Just because I know what 2% is as a decimal. 2% as a decimal is 0.02, and obviously I know that I need to do 1 plus 2%, which gives me 1.02. What that is 102% basically, isn't it, as a decimal? So the 1 means 100% plus whatever the rate is, and then to the power of 4. You can do either of these, it's whichever you're comfortable with. Do you prefer to just memorize the formula? Are you someone that works with percentages as fractions? Are you someone who works with percentages as decimals? It's very personal, but these are the same thing. So let's grab our calculator. I'm just going to type it in. I'll type it in the way that I've got the top one, because I know that's how my formula is. So 3,000 times by, open the bracket, 1 plus fraction, 2 over 100, close the bracket, and then to the power. You see this, if you're looking for powers that aren't just squared, it's the one here where we've got x to the power and then like a box basically. Your calculation might not be exactly the same as this, but hopefully they're kind of similar and you'll be able to find all these things before the exam. So power of 4 and then press equals. You just need to write down this number. Now it is to multiple decimal places, and you're probably thinking, well, it doesn't tell me how many decimal places to round it to. It doesn't technically matter. I personally just like to stick to doing 2 decimal places because it's money, and money has 2 decimal places. So that would be £3,247.30. That would round to 30p, wouldn't it? Because of the 6. So £3,247.30. Now, the reason why I said earlier that's the value of the account is because clearly, I mean, if you were to earn that much interest, that would be insane. That would be really good, but it's unlikely, okay? This is what's in Jane's account after 3 years. Obviously, still, the 3,000 is still there. If Jane takes the 3,000 out of her account, she can't earn interest on it, right? So obviously that's still there. And then anything that's beyond £3,000 is obviously then the interest. So that's why you have to be really careful. Double check your question. What have they asked for? In this case, yeah, they've asked for the value of the account. So this is your answer. 3,247.30 is your answer. But you can see I put part A because I'm going to use the same example and show you part B, where they might ask you what is the interest, or what interest did she earn, how much interest, and so on. Also, just before we move on, I'm going to just type this version in so you can see you'll get the same exact answer, okay, just so you can see that. The 3,000 times 1.02 to the power of 4, obviously that's just the 1.02 to the power of 4. Can you see I've got the exact same answer? Okay, so I know I've written the formula like that, but it's just to emphasize the fact that obviously the percentage has to be as a decimal, right? So 0.02 it was. Okay, so you can see here we've got exactly the same question. Jane, we've got £3,000, we've got 2% interest, we've got 4 years. However, the question now says, how much interest did she earn? So in this case, it's kind of an extra step. You have to use this formula to give you the value of the account. So obviously I know we already did that. Okay, so that was the value. I've just copied that from the previous page. So that's the value of her account. To find the interest though, you kind of have to do an extra step, and you have to basically take this and just subtract the initial amount. Okay, so we're going to do 3,247. I mean, you can probably see the answer from here, but you know, just for the sake of getting the working out marks, write it down. Minus 3,000, which was our initial amount. Obviously, that's going to leave you with £247.30. That is the interest across all 4 years, all added together. That's what Jane earned in terms of interest. So just be really careful. Have they asked for the value of the account? In which case, just use the formula. Have they asked for the interest? Okay, step 1, use the formula. Step 2, work out the difference to get the interest. Okay, hopefully that's enough explanation. Let's just go through a variety of different questions then. From this point, a lot of the questions are very similar. Kind of get a pattern in terms of, you know, you're looking for 3 pieces of information, as we already said. We're looking for the initial amount, we're looking for the percentage interest, and we're looking for the time or the number of years in this case. So, Harry invests $1,600 into an account paying compound interest at a rate of 4.5% per annum. What is the value of his account after 2 years? So, we know we need to use our formula. I'm just going to go through and highlight. The initial amount is obviously $1,600. The interest rate is obviously 4.5%. And the value of his account after 2 years. So 2 years is the time. So what I would do, and you do have to write this down in the question, even though I know it's just kind of, you're going to type it directly into your calculator, but you do need to write it down to get the marks. 1,000 times by 1 plus 4.5 over 100 to the power of 2. That's what you need to put in your calculator. So let's chuck that in now. So 1,600 times by, open bracket, 1 plus 4.5% over 100, close the bracket, to the power of 2. There we go, £1,747.24. So I'm going to write that down. £1,747.24. Now again, double check, we know that this gives us the value of his account. Obviously that's clearly including his initial investment of 1,600, and it does say here what is the value of his account, so that would be your final answer. Don't need to do anything more for this particular question. And that's it, simple as that. Okay, as I said, we're going to get some that are a little bit harder. You can see here we've got an example where, well, it's not necessarily harder, it's just a bit longer really, and you can get a few more marks for it. The reason being is you can see we've got 2 people, 2 scenarios. Okay, so it's going to take us just a bit longer. We're basically going to do the same process twice. So we've got here, Allie invests £2,200 in an easy access account. You can see here, easy access account. So I'm going to write down Allie's name just so we can make sure we don't get them mixed up. Callum invests £1,800 in a regular savings account. So Callum is over here. Who will earn more interest after 3 years? So, okay, first of all, we know we're looking for the interest. Now we're going to be applying this formula, but to the 2 different situations. So I'm just going to put a line down the middle so I can focus on them both individually. So you can see we've got 2 different initial investments, obviously for the 2 different people. We've also got 2 different rates. Now double check that they're both compound interest, okay? In this question they are both compound interest, but sometimes they might mix simple and compound interest together, so just be really careful about that. And they do have the same amount of time though, they're both for 3 years. So let's work out Allie first. We've got her initial investment, her initial amount is 2,200 times by, open the bracket, 1 plus her interest rate is 1.5 over 100 and then to the power of 3 years. So we get our calculator. 2,200 times by 1 plus 1.5 over 100 to the power of 3 equals 2,349 to 2 decimal places. Okay, now as we said, it is asking for the interest, and because they both have a different starting amount, initial amount, we can't really just see whose answer is bigger, right? Because they've started at different places. So I am going to subtract 2,200 from this to get my interest. So 2,349 is the value of Allie's account after 3 years. Subtract her initial amount, the initial value, and that should leave me with just £100, 49 pence. So that's the actual interest. So we've done Allie, now we just need to do Callum. Now we're going to do exactly the same thing, but obviously remember, he's got different numbers. So his initial amount is 1,800 times by 1 plus his percentage is 2, so 2 over 100, and still for 3 years. So we bring the calculator back, we type in Callum's version. We get £1,910.17. So £1,910.17. Okay, again we want to compare for the interest, so I'm going to take the value of his account after 3 years, which is the 1,900 number, minus the initial amount, which was 1,800, £110.17. Okay, now this is not the last bit, right? Because, yeah, okay, we've worked out the interest for both. However, they've said, who will earn more interest? So they actually want us to write a conclusion. And I don't mean like a sentence, I just mean clearly indicate, is it Allie or Callum, basically. So I'm going to put these little 3 dots, which means therefore, and obviously who has the more interest? Well, £100 versus 110. Okay, obviously that's going to be Callum. So just make it really clear who your decision is, okay? Otherwise, that's it. It wasn't much harder than the ones we've already done. We just had to do the same process twice. If you feel like you've got the hang of it now, give this one a go. It's pretty much the same question that we've just done, and then let's go through it. So we've got Aaron invests £600 in Bread Bank. Kiera invests £550 in Jam Bank, whose account is worth more after 5 years. So this one is saying worth more, not interest, but who has the most money in their account after 5 years. So we've got 2 different scenarios again. Aaron has 600, Kiera has 550 for the initial amount. In terms of percentage rate, we've got 0.5% in Bread Bank and we've got 2.8% in Jam Bank. Okay, both compound interest as well. And both of them have 5 years. So I've just drawn another line down the middle to split up the 2 options. This one is for Aaron, this one is for Kiera. Okay, so for Aaron, we've got initial amount 600 times by 1 plus 0.5 over 100 to the power of 5 equals calculator. So we get £615.15. Okay, so that's the value that Aaron has after 5 years. So obviously that includes the 600 initial amount and plus his interest. So now let's do it to Kiera. So 550 times 1 plus 2.8 over 100 and also to the power of 5. Then we put that in the calculator. That is £631.43. And again, that is the value of Kiera's account after 5 years. It includes the 550 plus all her interest. In this case, because it's saying whose account is worth more, that means the value, doesn't it? Who has the highest value? Okay, well, in this case, clearly, it's Kiera. So even though Kiera invested less money initially, she had a better account because it had a much higher interest rate. Okay, this is our last question. This time we have got 2 options, but they are 2 different banks, but the same person and the same investment. So this is why you've got to read all of these questions super carefully because there's a lot of ways they could trick you and you don't realise exactly what they've written. So in this context, we've got Dani wants to invest £7,500. Okay, that's our initial amount. Which bank would give her a better return after 3 years? So they've told us the years, 3 years worth. Now if we have a look, we've got Bank X. Bank X is 2%. If you have a look, compound interest. That's why you've always got to double check. 2% compound interest. Bank Y is 2.8% simple interest. Okay, so they could bring both of them into the same question. Just be really careful. That's why even if you're higher tier, you still need to know simple interest because they could throw both of them at you. So let's go through and do the formula for both scenarios. So even now I'm still going to draw a line down the middle. So the first option is for bank X. Obviously the initial amount is the same this time for both options. We've got 7,500 times 1 plus, now this one's 2% over 100 to the power of 3 years. Okay, we're using the compound interest formula because it's compound interest, obviously, right? The simple interest, don't be mistaken, we're not going to use compound interest formula for that. Okay, so obviously type that into my calculator. That gives me 7,959.06. Okay, now let's look at the simple interest. If you haven't seen that video already, I'm going to link it now, go back and check it out. Basically, it means we need to work out 2.8% of 7,500. And then for 3 years, that's the amount of money that they're going to get. So to work out 2.8%, I just have to times by 0.028. Okay, that's effectively the same as doing 2.8 over 100, just converting it into a decimal. So 7,500 times 0.028. Okay, so that's £210. So what we're saying in this case for simple interest is that every year Dani is going to get £210 interest. Now we know it's for 3 years, so in terms of simple interest, we just have to do 3 times by 210, okay, which should give us 630. So that is the total interest that Dani will get. Now we can either compare in this case because it says which account would give her the better return. When they say like return on your investment, we're just saying like which one is going to give her more money, which one is she going to earn more money from. So either you can compare the interest for both, or you can compare what the value of the account would be after 3 years for both. It doesn't really matter in this case because the starting amount is the same. Let's say we compare the interest. So over here we're going to have to work out the interest because that is the value of her account, isn't it? That's including the interest. So to find the interest we have to just subtract the initial amount, which should give us 459.06. Okay, that's now the interest. So if you had £7,500, for example, and you had these two options, which bank account would you put it into, or which bank would you give it to? Obviously the one that's going to give you more interest, i.e. a better return. That's the same as saying more interest. Obviously it benefits me more to choose bank Y because I ideally want to earn more interest, don't I? So again, you have to choose. Therefore, bank Y. And that's it. So thanks for watching this video. That was the starting basis questions for compound interest. If you're doing higher tier in particular, definitely check out the next video, which is on harder compound interest. And the last video will be compounding for decreasing values. Obviously, interest is an increasing situation. We're earning money, but you could have the concept of compounding for decreasing values as well. So check out those last 2 videos. Make sure to subscribe and leave down below any comments or questions that you might have.